Hello. Today we're going to go over carbohydrate regulation and specifically talk about what's going on in your liver cells and your muscle cells. This video specifically is going to focus on high blood glucose levels. So you have high blood glucose, so then your hormone is going to be insulin. Insulin is going to bind onto RTK, which are receptor tyrosine kinases. This is going to lead to autophosphorylation. And I recommend you speed this video up because sometimes writing can take a while, so you might want to go through it quicker yourself. This autophosphorylation is going to then activate insulin-sensitive protein kinase. This insulin-sensitive protein kinase is then finally going to lead to phosphoprotein phosphatase, or as you might know it, PP1. And this is going to be really important in the following steps, as this phosphatase activity is going to remove phosphates from certain enzymes, which is either going to activate or inactivate them. So a big clarification here that you need to know is that a kinase is going to phosphorylate, whereas a phosphatase is going to dephosphorylate. So once you have this phosphoprotein phosphatase, this is going to act on your glycogen synthase and your glycogen phosphorylase. So we're going to go first to glycogen synthase. Now, if you have high blood glucose in your body, you are going to want to activate your glycogen synthase so that you can create these glycogen stores and save all of this large concentration of glucose for later when you might need more energy. So you want to activate glycogen synthase, and you are going to activate it by using this phosphatase activity to remove a phosphate from glycogen synthase, which is going to put it in the A conformation. And you can just think A is active, whereas before we activated it and took off the phosphate group, it was in the B conformation, so it was glycogen synthase B, which then went to glycogen synthase A, active form. Now we are making glycogen. So this is going to increase glycogen storage. Okay, now we're going to discuss glycogen breakdown. So here we have glycogen phosphorylase, which is the enzyme used to break apart glycogen. And if we already have high blood glucose, we don't want to break down our glycogen because then that will result in even higher blood glucose levels. So we want to inactivate this enzyme, which is then going to turn this glycogen phosphorylase A into glycogen phosphorylase B, which is the inactive form of it. And this is going to inhibit glycogen breakdown. Okay? So far we're talking about all of this in terms of the liver. So this is what's going on in your liver right now. So it has these effects on glycogen storage and glycogen breakdown. However, your liver also has an effect on this bifunctional enzyme. So here, we're going to have PFK2/FBPase2. And this right here is the bifunctional enzyme. You can tell it's the bifunctional enzyme because of these two here. There is another PFK1, but that's used in glycolysis. So note that there's a 2 here and a 2 here. That denotes it as the bifunctional enzyme. And this is only present in the liver. So in your muscle cells, you will not have this bifunctional enzyme. So we have phosphatase activity. So it is going to remove a phosphate from this bifunctional enzyme. When you remove a phosphate from this bifunctional enzyme, you are going to be activating PFK2. And when you activate PFK2, you're going to increase concentrations of F26BP. So you're going to increase that concentration because this bifunctional enzyme works to transfer so we have a fructose 6-phosphate up here. This kinase is going to phosphorylate that to then get fructose 2,6-biphosphate, whereas the FBPase activity would remove a phosphate from this fructose 2,6-biphosphate, take off the phosphate at the 2 position and turn it back to fructose 6-phosphate, which is no longer going to be an activator of PFK. So this fructose 2,6-biphosphate is going to activate PFK1. So if PFK1 is activated, this is going to increase glycolysis. The only thing that needs to be noted here for the difference between liver and muscle cells, and I'm going to note this in the orange marker, is that in muscle cells, if you have high ATP, I'll put muscle right here. If you have high ATP, so say you ate a large pizza and now you were just watching TV, relaxing, so you have high energy, you have a lot of ATP, however you have low energy demand, then you're going to have this high ATP inhibit glycolysis by inactivating, inactivating PFK1. And this is going to inhibit glycolysis. And this makes sense because if you already have a lot of energy, then you don't need glycolysis to occur because glycolysis is used to create more energy. But here we have a low energy demand, so we are satisfied with the amount of energy we have, so we can inhibit glycolysis by inactivating this PFK1.
The Teaching Center, UF's Learning Resource Center.